Hello students, how are you all? Welcome to your own classes, S2 classes, Subra Saraswati classes. In the last class, we have discussed the rules to find the oxidation number. And today class aim to do the question. IIT JEE, first I will solve you some question from my side. Then I will solve IIT JEE question also. So that you will be 100% sure regarding that. Before starting the class, one motivation video for you, one motivation line for you, कि how much bad you are, never give up. Try and try and try and try and try. Trust me, success must come to you at any cost if you are a hard worker, men or women. Now, welcome to the class, having after the motivation. Over here I have written some question, and in that I have underlined, suppose over here phosphorus, over here sulfur, over here nickel, over here iron, over here chromium, over here iron, over here nitrogen, over here xenon, and I am asking find the oxidation number and oxidation state of the following things. The first, what you will do, you will say, sir, in the rules we have studied that hydrogen has 1, 3 hydrogen is there, so 1 into 3. Phosphorus we have to find, so X plus oxygen has -2, but 3 oxygen is there, so -2 into 3 is equals to overall this compound has 0 charge, so equals to 0. From here you will get 3 plus X minus 6 is equals to 0. From here you will get X minus 3 is equals to 0. From here you will get X equals to plus 3. Now the way of finding the oxidation number like this, is valid not for all the elements. Means what I am trying to say, the most of the people called this oxidation number as average oxidation number or oxidation state. Now they are asking find the individual oxidation number, oxidation state. Find the individual oxidation number or oxidation state of phosphorus in H3PO3. So for that you should have to be familiar with their structure. P double bond O, H is there, O, H is there, over here H. Now if you cross check, you will say, ki sir, over here we will have hydrogen oxygen. First check, it will get positive. Oxygen is more electronegative, it will get negative. Over here it will get positive, it will get negative. Similarly in phosphorus and oxygen, it will get negative, it will get positive. It will get negative, it will get positive. Oxygen has double bond, it means it will get 2 negative, it will get 2 positive. Now from here phosphorus is more electronegative than hydrogen. It means phosphorus get 1 negative, hydrogen get 1 positive. Now if you calculate the oxidation state of phosphorus over here, the 2, 1, 3, 1, 4 minus 1 is 3. Sir, what is the difference between average oxidation number and real individual oxidation number? No. Which means what I am trying to say, understand my point. After that I will solve all the question. I am trying to say that in 90% cases, like this formula you will use and you will get the oxidation number, that is the individual oxidation number or average, both is correct. Means this formula is valid to find the oxidation number, except for 12 compound that I am going to write. For that 12 compound, if you find the oxidation number like this, and if you find the oxidation number by drawing the structure, that too will be different. And in that, by drawing the structure, whatever be the oxidation number you will get, that is the correct. By this formula, it is incorrect. Understanding? So most of the book will say that this is average oxidation number, and the oxidation number that you will find by drawing the structure is the individual oxidation number. But it is very tough to understand and learn all the structure given in the organic compound or all the structure given in the chemistry. So I will tell you that most of the cases, if you use this formula, you will get the correct oxidation number, except for 12 compound. How many compound? 12 compound. So especially I will draw the structure of the remaining 12 compound by which their structure is needed. You cannot find the oxidation number like this. It means except for that 12 compound, Whenever the question is given, if that question does not belong to that 12 compound Prabhat sir has given, it means the remaining compound, you can find the oxidation number like this. No need to learn the structure. Suppose over here there it is the SO4 2 minus. I am saying that whatever with the formula I have written over here, for that structure is not needed. What you will say, कि sir sulfur has X plus oxygen has -2, 4 oxygen -2 is equals to overall charge is -2, तो -2, तो x minus 8 is -2, तो x you will get -2 plus 8, तो x you will get plus 6. It means the oxidation number or oxidation state of sulfur in SO4 2 minus is plus 6. Getting? Suppose I have over here find nickel, we will take nickel as X, and in the last class I have told you either either carbon monoxide, not cobalt. Cobalt is CO, smaller O. Bigger O is carbon monoxide, or it is given NH3, or it is given H2O. In that cases their oxidation number or oxidation state is 0. So x plus 4 into 0 is 0. So x you will get 0. It means 0 is the oxidation number of nickel in this following compound. If you have to find the oxidation number of iron in Fe 0.93, if Fe2O3 is given, how can you find? You will write, sir, Fe, we will have to find for Fe, the 2x plus 3 into -2 is 0. So 2x is equals to minus plus 6. So x you will get 6 upon 2, that is 3. But over here in place of 2 it is given 0.93. So what you will do? 0.93 into x plus 1 into -2, because oxygen has -2 and 1 oxygen is 0. From here you will get 0.93 x is equals to plus 2. From here you will get x is equals to 2 upon 0.93. Decimal remove 100. It means oxidation state of Fe 0.93O. In that Fe has 200 by 93. It means oxidation state of Fe in this formula is 200 by 93. Now this structure has a name, a special name, chromyl chloride. You will have sometimes, I have seen the question, I will solve the question over here for IIT JEE also. In that they will directly give the name. So you have to know their formula is CrO2 Cl2. So what you will do, Cr you will take X, O you will have -2, 2 oxygen is there, plus chlorine has -1, 2 chlorine is there, so 0. So x minus 4 minus 2 equals to 0. So x minus 6 is 0, x you will get plus 6. Is there any problem? It means, again, don't get confused. What I am trying to say, that whenever I started the compound in which you cannot find the oxidation number like this, for that compound, I will give you the structure. So first I will written all the compound over here in which you can find the oxidation number by using this x minus 2 like that. Likewise, I am finding. After completing this, I will write only those compound, for which a structure is needed. If you try to find the oxidation number like this, it will going to be wrong. Getting my point? In this, it is known as Mohr salt, and sometimes they will give you the formula directly, Mohr salt, what is the oxidation number or oxidation state of iron in Mohr salt. You will have to directly say that in Mohr salt, this will not break, only FeSO4 will break as Fe2 plus SO4 2 minus, the oxidation number or oxidation state of Fe in Mohr salt is plus 2. Getting? Now the remaining thing you have written, I am just going to erase the things. So these are the questions that I have given that can be solved like this. After completing this question, I will give you the question in which the structure is needed. Getting my point? Write all the things written, sir. Now suppose I am going to erase this part. Now we will have the another structure, this one. We will have N2H5 whole twice SO4. Suppose, sir, I have written over here AlCl3. What does it means? Al has 3 plus, Cl has 1 minus. It will combine like this. Class 9th you have remembered. It means Al has 3 plus, Cl has 1 minus. Similarly, it can break like this. You can break this compound like N2H5 to the power 1 plus, and this 2 goes SO4 2 minus. Getting my point or getting confused? No, sir, we are getting our point. And if anything I have written and you are not able to write, go with the back in the video and you can write. Now over here, SO4 2 minus, I have already find that S has plus 6 in SO4 2 minus. In this you have to find individually. If they are saying for find the N, you will have to find like this. If they are saying to find for S, you have to find like this. and now over here you will say 2x plus 1 into 5 is equals to 1. So 2x is equals to 1 minus 5, that is 2x is equals to minus 4, so x you will get minus 2. It means in this formula the oxidation number or oxidation state of nitrogen is minus 2 and sulfur is plus 6 after breaking it. Last question we will have question number 8, and in question number 8 they have given XeF5 1 minus, and in that you will say, sir, Xe we will have to find the oxidation number, so we will take it as X. Fluorine is always minus 1 is equals to minus 1 because minus 1 is the total charge. So X minus 5 is equals to minus 1. X you will get minus 1 plus 5. From here X you will get plus 4. It means these most of the cases, 90% cases, 99% cases, we can find the average oxidation number or individual oxidation number. If oxidation number asking like this way, X taking like this, that I have found. Now I am going to give you the special question in which if you use this type of logic you will get the wrong answer, and that total special I have is 12. On that 12 basis you are able to do all the JEE question, and I will try to solve all the JEE question in front of you. Write all the things. Now I'm going to erase it. Write fast my dear friends, write fast. Now whatever be the structure I am writing from now onwards, whatever be the structure I am writing, in that you will have to draw the structure, then you are only able to find the oxidation number. Suppose if you use the previous logic and you will say you find the oxidation number of chromium in this and chromium in this, and you will say, sir, X plus 5 into minus 2 is equals to 0 because oxygen has minus 2, so X minus 10 is equals to 0, so X is equals to plus 10, and this is the oxidation number or oxidation state of chromium, and you will take plus 10 in JEE exam and you will get wrong. It means from now onwards, first, second, like that I will write total 12 structure. For that you cannot find the average oxidation, you cannot find like this only, you will have to find by using the structure, and the structure of this one is butterfly structure. How is their structure? Butterfly structure. Now if you see their structure is Cr O like this, O like this, and double bond O over here. Now if you find the oxidation number of chromium, you will say that this oxygen has minus 1, because of this oxygen it will get plus 1. This oxygen has minus 1, because of that it will get plus 1. This oxygen has minus 1, because of that it will get plus 1. This oxygen has minus 1, it will get plus 1. This bond will break and it will get 2 minus and it will get 2 plus. Over here oxygen has 0 and 0. No electronegativity difference, 0 and 0. So what is the total oxidation number of chromium? So because of this 2, because of this one 3, because of this one 4, because of this one 5, because of this one is 6. It means in this oxidation number of chromium is plus 6, not plus 10. By the formula we are getting plus 10, it is incorrect. Now what is the oxidation number or oxidation state of oxygen in this case? So this oxygen has minus 1, minus 1, minus 1, minus 1, and this oxygen has minus 2. It means oxygen has minus 2 and minus 1, both oxidation state, because some oxygen has minus 2 also, some oxygen has minus 1 also. What is the peroxy linkage? Number of peroxy linkage. What is the, now from now onwards I am writing PL. You have to understand this is meaning number of peroxy linkage, and I have told you peroxy linkage are those linkage in which there is a oxygen bond, single bond, and each oxygen has minus 1 charge. So see these two oxygen, minus 1 single bond with oxygen, one peroxy linkage, and over here one peroxy linkage. It means number of peroxy linkage in this structure is how many? 2. Now similarly we will draw this, try to find the oxidation number by using this, we will get wrong. So for that we will have to know the structure of this compound, and the structure of this compound is CrO like this, then we will have OK, then we will have OK, then we will have OK. Only 12. I told you na ki you didn't have to learn lots of structure. Only 12 I am writing. In that basis you are able to do the JEE question. First and second completed. Now over here if you say this oxygen and this oxygen has 0 0 because no electronegativity difference. Over here this has 1 minus, this has 1 plus. Over here this has 1 minus, this has 1 plus. Now this oxygen has 1 minus, because of that chromium get 1 plus. This oxygen has 1 minus, because of that chromium get 1 plus. This oxygen has 1 minus, because of that chromium get 1 plus. Now in this oxygen it is 0 and 0. In this oxygen 0 and 0. In this oxygen 0 and 0. Now potassium, it has 1 minus, it has 1 plus, it has 1 minus. It has 1 plus, it has 1 minus. It has 1 plus, it has 1 minus. Now if I am asking that what is the oxidation number or oxidation state of chromium, you will say, sir, 2, 1, 2, 3, 4, 5. It means oxidation number or oxidation state of chromium is plus 5. Now I am asking what is the oxidation number or oxidation state of oxygen. You will say over here, sir, minus 1, over here minus 1, minus 1, minus 1, minus 1, minus 1. Everywhere there is minus 1. How many number of peroxy linkage it has? So this oxygen single bond, 1 minus 1 minus, 1 peroxy linkage. This oxygen single bond, 1 minus 2, 3 and 4. Like that we will have over here 4 peroxy linkage. Now why I have left this space? To told you that whenever they are asking to find the oxidation number of these types of compound, the 12 structure that I am going to dictate, so for that you have to know the structure. But if they are asking directly the question, how many number of peroxy linkage the given compound has, suppose the question asks not to find the oxidation number of chromium, but the question asks find the peroxy linkage in CrO5. So for that, a structure not needed. For that, I will give you the tricks. Trick to find peroxy linkage without drawing this structure. Sir, don't make that type of sound. It will become irritating for us in the videos. Okay. So without drawing the structure, how can you find the peroxy linkage? How many number of peroxy linkage the given structure has? The first rule, find average oxidation number or oxidation state. Sir, you are saying that the average oxidation number is this. Like that, if we are finding the oxidation number, like this, if we are finding the oxidation number, that is known as average oxidation number. And sometimes average oxidation number is equal to the actual oxidation number. But you have told me that in 12 structure that you are drawing right now, in this average oxidation number you didn't have to find. You have to find the drawing the structure. So why we are finding? So this rule is for only to find the peroxy linkage. Don't get confused. Understand easily that previously whatever with the structure I have written, that you can find by using the formula. But right now I am writing the structure, 12 structure in which I have written 2. In that you have to know the structure. But for finding the peroxy linkage in these types of formula in which a structure is needed, without drawing the structure you will find the peroxy linkage. In that the first rule is find average oxidation number or oxidation state. After finding the average oxidation number or oxidation state, second point you should have to be familiar. Like suppose we will have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And if anybody is asking, what you will have to learn it, what is the maximum oxidation number of this compound? So lithium has 1. Maximum oxidation number is the valence electron number. Maximum oxidation number is the valence electron. If you do the electronic configuration of lithium, what you will get? K2L1. So 1 is the maximum. Beryllium, K2L2, so 2 is the maximum oxidation number, plus 2 or 2. What is the over here? K2L3. Boron has 5 atomic number, so like that 3, like that 4, like that 5, like that 6, like that 7. So in the lithium group you have to learn all the things. Hello Lily, Nizam, coming run fast. If you know the periodic table, because you are in the first year now, you already know about the periodic table. After knowing the periodic table, suppose fluorine has plus 7, the chlorine also has plus 7, bromine also has plus 7, iodine also has plus 7, is the maximum oxidation number. Oxygen has, then sulfur also has, selenium also has, tellurium also has, like that. If nitrogen, then phosphorus also have, Nigeria, Pakistan, Australia also means arsenic also has, antimony also has, like that. You should have to be familiar with the maximum oxidation number of these compounds. In this compound only peroxy linkage is formed, and another one we will have chromium and manganese, and the maximum oxidation number of chromium is plus 6 and the maximum oxidation number of manganese is plus 7. First point, you should have to be familiar, you should know how to find the average oxidation number of any compound. It means first find the average oxidation number of any compound, then check that in out of these which compound are there. According to that compound, check their average oxidation number. Now cross check that their average oxidation number and maximum oxidation number. If average oxidation, not average, if average oxidation number is greater than maximum oxidation number, then it has peroxy linkage. And if average oxidation number is less than maximum oxidation number, then it does not have peroxy linkage. And now suppose I am just going to do this question, and they are asking find the number of peroxy linkage in this compound. So I didn't know the structure, I am following this rule. So I am saying that first we will have the rule to find the average. To find it average, either it is wrong or right, find average minus 2 equals to 0, so H you will get plus 10. And in this we will have to find the chromium, and this is their average oxidation number. What is the maximum oxidation number of chromium? So sir, maximum oxidation number is plus 6. Now check these two. Yes sir, average oxidation number is greater than maximum oxidation number. It means it has peroxy linkage. Now the question arises, how many peroxy linkage visible? Yes, visible. How many peroxy linkage it has? So for that there is a formula you have to use, that to if case number first we will have, if one central atom, then peroxy linkage is average oxidation number minus maximum oxidation number divided by 2. And second we will have, can I erase this part, this upper portion, you write it. I am not erasing this part, so you will understand that whatever be the number of peroxy linkage I am getting is correct for this question or not. And it is saying that case number 2 we will have, if more than one central atom. In this, the formula you have to use for the peroxy linkage is average oxidation number minus maximum oxidation number. Now in not divided by 2, only this. Now in CrO5, how many central atom? Only one Cr. No? Central atom is, suppose I have written H2S2O8, then in that 2 central atom. I will solve the question like this also. So in this, how many central atom? One central atom. Use this formula. So number of peroxy linkage is average oxidation number. How much it is? 13. Minus maximum oxidation number. How much it is, sir? 6. Divided by 2. So 4 divided by 2. Cutting it 2. Number of peroxy linkage in CrO5 is 2. So without drawing the structure, you will come to know. Okay. Write fast. I will solve this question also. This logic you have to follow. Now can I erase this? Now I am solving the second question. Because I have already found 4 peroxy linkage. Now without drawing the structure, first you will find the average oxidation number. So 3, potassium has 1, 3 into 1 plus X plus 8 minus 2 is equals to 0. 8 into minus 2 because oxygen has minus 2. So 3 plus X minus 16 is 0. So what you will get over here, X is equals to how much? 3 minus 16 is X minus 13. Yes. Is equals to 0. So X you will get plus 13. Now this is average oxidation number. Average. And what is the maximum for chromium? Because in this case again chromium, so maximum is plus 6. Yes sir. Average oxidation number is greater than maximum oxidation number. Yes. It has peroxy linkage. Now find the number of peroxy linkage. The number of peroxy linkage, central atom only one chromium. Use this formula. Average is 13 minus maximum is 6 divided by 2. You will get 7 by 2, that is 3.5. Now class 6 level logic you have to follow, that if it is 3.1, so overall it will become 3, 3.2 became 3, 3.3 became 3, 3.4 became 3, but 3.5 converted to 4, 3.6 converted to 4, 3.7 converted to 4, 3.8 converted to 4, 3.9 converted to 4. So this is the average round of rule, not first year rule. The 10th class, you know na ki sir 3.5 is converted to, if it is less than 5 then 3, if it is more than 5 then became 4. So 3.5 means approximately it is 4, and number of peroxy linkage in K3CrO8 is 4. Getting? So this is the short trick to find the number of peroxy linkage, and this is the diagram by which you can find the oxidation number of the compound with drawing the structure. So 2 compound we have completed, that in which we will have to draw the structure. Now remaining 10 I will dictate in this video only, right? First, it means up to now I have dictated you that without drawing the structure, you can find the oxidation number of most of the compound. But 12 compound are there. For that you have to know the structure of that following compound. In that I have given you 2 compounds, CrO5 and K3CrO8. But for finding the peroxy linkage, you didn't have to learn the structure. By using this formula, you can find the peroxy linkage. It means for finding the oxidation number only, you have to be familiar with the structure of this compound. Right, first, now I'm just going to give some more structure in which diagram is needed. Now the third structure we will have Br3O8 C3O2. Fourth one, it is also called carbon suboxide, and Na2S2O3 sodium thiosulfate. This is very important. Before doing my video complete up to this, try yourself, you will get wrong, guaranteed. Now come over here. For this, the structure is something like Br, single bond Br, single bond Br, over here double bond O, 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 double bond O. The structure of this one is C double bond C double bond C double bond O, double bond O. The structure of this compound is S double bond O. Over here we will have O, N, A. Over here we will have O, N, A, 2Na, 2SO3. Now these are the structure of this compound. Now we will have to find the oxidation number. You will directly say this bond break 2 minus 2 plus, this bond break 2 minus 2 plus, more electronegative rules you have studied already. Sorry, 2 minus 2 plus, it will get 2 minus 2 plus. The over here break 2 minus 2 plus, 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 over here break 2 minus 2 plus. It means over here you are getting the oxidation number or oxidation state of bromine is 6. Over here you are getting 4 only, because this Br is the 0 0 na? This Br is the 0 0. Now I am not writing 0 0. Over here you will get 6. It means oxidation number or oxidation state of Br is 6, and over here plus 4 also. Oxidation number or oxidation state of oxygen is, you will say everywhere there is 2 minus. Over here number of peroxy linkage, you will say every oxygen has double bond, no oxygen bond. The 0 peroxy linkage, if you want to find with the tricks without drawing the structure, so first you will find average oxidation number 3x plus 8 into minus 2 is equals to 0. So 3x is equals to, you will get 16. So you will get x is equals to 16 by 3. 3 5s are 15, 1 3, 5.3 approximately, and their maximum oxidation state, it comes in the group of fluorine. The bromine has plus 7. Over here average, and I told you that if average is less than maximum oxidation state, then it has no peroxy linkage. It means it has no peroxy linkage. For the condition for having the peroxy linkage is average is greater than maximum, but over here average is less than maximum. Getting my point? If average is less than maximum, then they have no peroxy linkage. Only in the case when average is greater than maximum, then they have peroxy linkage. Over here, this bond break, it will get 2 minus 2 plus. This bond break, it will get 0 and 0. This bond break, it will get 0 and 0. This bond break, 2 minus 2 plus. So over here the oxidation number or oxidation state of carbon is over here plus 2, over here plus 2, over here 0. So 0 and plus 2. The oxidation number or oxidation state of oxygen is minus 2, over here also minus 2, over here minus 2. Number of peroxy linkage is 0. If you want to use the trick, you can use that trick. Suppose I am using over here 3x plus 2 into minus 2 is 4 is equals to 0. 3x minus 2. Over here you will get 3x equals to 4. So x you will get 4 upon 3. That is 3 1 the 3 is 1.3 something, and it has maximum oxidation number of carbon. So carbon has plus 4. Over here average oxidation number is less than maximum oxidation number. So no peroxy linkage. The condition for peroxy linkage is average is greater than maximum. Over here smaller. Now very good question. Over here if you break these two, you will get 1 plus 1 minus. Over here 1 plus 1 minus. After breaking this, what you will get over here? 2 minus and 2 plus. Now in this case, you are thinking that this sulfur and this sulfur is same. But check over here. If you find the hybridization of this sulfur, then 1 sigma, 2 sigma, 3 sigma, 4 sigma. It means 4, it means sp3. But if you find the hybridization of this sulfur, it has 1 lone pair, 2 lone pair, because 1, 2, 3, 4, so 5, 6, 7, 8 needed for the atom to complete octet. So 2 lone pair, 1 sigma. It means 2 lone pair plus 1 sigma is 3, and it has a hybridization of sp2. And as you know that electronegativity of sp is greater than sp2 is greater than sp3. It means this is more electronegative than this, and more electronegative bond can break, and it will get 2 minus and it will get 2 plus. Over here oxygen get sigma I am removing. So this is the only case in which same bonding is breaking. Over here 1 minus 1 plus. Over here 1 minus 1 plus. So 2 with this, 2 with this 4, 1 with this 5, 1 with this 6. The oxidation number or oxidation state of sulfur is minus 2, and for this 2, 1, 3, 2, 5, 1 plus 6, minus 2 as well as plus 6. If I am saying what is the oxidation number or oxidation state of oxygen, so over here 1 minus because of this sodium and 1 minus because of sulfur. So 2 minus, over here also 2 minus, over here also 2 minus. So over here they have 2 minus, but no peroxy linkage, oxygen bond is not there. If you want to cross check, you can cross check like this. You will get no peroxy linkage. It means number of peroxy linkage over here is 0. Write fast. We have completed 3, 4. This is the 5th number. Now we are going with the another one. Total 12 is there. Write fast, write fast. Next we will have this structure. Now whenever I am writing the name of any structure, learn the name. Sometimes they will give you the question according to the name. And as I have seen over here, the time is running very fastly. 32 minutes, 33 minutes completed. So after completing all 7th number we have, after completing 12 number, the question of IIT JEE that is given in some books. You have buy the book 23 year IIT JEE question in that. 12 question total given, 12 to 13 question. Next video I will do that, because if one video is going to be more than 1 hour, it is going to be complicated. So I will increase the number of videos but not the size of the videos. 40 minutes, 45 minutes, 1 hour maximum. Now over here the structure of this compound is S double bond O, double bond O, 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 H. Over here O, H. This is the structure of this compound. And the structure of this compound is S double bond O, double bond O, 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 S, double bond O, double bond O, O, H, O, H. And now over here I have written H. If they will give you Na2SO5, don't get confused. Write over here Na, same thing. If they have given Na2S2O8, write Na in presence of H. Now if I give you the structure, so you are able to draw it, do it. Now this break 1 minus 1 plus, this break 2 minus 2 plus, this break 2 minus 2 plus, this is 1 plus 1 minus, this break 1 minus 1 plus, 1 minus, 1 plus, over here 0, 0, 1 plus, 1 minus. Now if anybody is asking what is the oxidation number of sulfur, you will say sir 2 to 4 to 6. Oxidation number or oxidation state of sulfur is plus 6. Oxidation number of oxygen over here minus 2, over here minus 2, over here minus 2. But over here minus 1, minus 1. It means oxidation number or oxidation state of oxygen is minus 1 and minus 2. Oxidation number or oxidation state of hydrogen, if hydrogen given, or if sodium given, then sodium is plus 1 and plus 1. Same the over here you will number of peroxy linkage. Number of peroxy linkage. The oxygen has single bond, it will get 1 negative, 1 negative. Correct. The rule for peroxy linkage is single bond oxygen, charge is 1 minus, it means number of peroxy linkage is 1. If you want to use the formula, you can use the formula and find it. Over here we will have 1 plus, 1 minus. Over here we will have 1 minus, 1 plus. This bond break 2 minus, 2 plus. This bond break 2 minus, 2 plus. This 1 minus, 1 plus. Over here 0, 0, 1 minus, 1 plus. This bond break 2 minus, 2 plus. Bond break 2 minus, 2 plus. 1 minus, 1 plus. 1 minus, 1 plus. Now over here what is the oxidation number or oxidation state of sulfur? The 2 because of this, 2 because of this, 4, 1, 5, 1, 6. Over here plus 6. Over here 2, 2, 4, 1, 5, 1, 6 plus 6. Oxidation number or oxidation state of oxygen is over here minus 2, over here minus 2, over here minus 2, over here minus 2, over here minus 2. So minus 2. Over here minus 1, over here again minus 2. So minus 2 and minus 1. How many peroxy linkage it has? 1 peroxy linkage, oxygen is the bond, and 1 minus 1 peroxy linkage. Now next we will go for Marshall acid. Sometimes they will give you directly Marshall acid. Write fast. And if you want to do over here with the formula, suppose I am going to do to find the number of peroxy linkage, you will find over here what? Sir, average oxidation number of sulfur. So we will have 2 plus 2x minus 16 is 0. So 2x is equals to 14. So x is equals to plus 7. Maximum oxidation number or oxidation state of, you will able to do that? Sure? So for sure na? So do it, try it. If not, then I will dictate. I am just going to write another question. Or I will do that. Tell me. I will complete. I will complete it. Maximum oxidation number over here. What you will get? Sulfur find in the group of oxygen. So oxygen has 6. So 6. Now over here, average oxidation number is greater than maximum oxidation number. It means yes, it has peroxy linkage. Now formula for finding the number of peroxy linkage. When one central atom, then average oxidation number minus maximum oxidation number divided by 2. But it has 2 central atom. It means directly average oxidation number minus maximum oxidation number 1 peroxy linkage. Sorry, plus 1. Minus not minus 1. Plus 1 is the peroxy linkage. So 1 peroxy linkage. Getting my point? I have found it because I trying that you will find, but you will get confused because you are going to use 7 minus 6 divided by 2 and will get 0.5. But over here 2 central atom. For 2 central atom we will have to use the formula average oxidation number minus maximum oxidation number not divided by 2. Up to that we have completed 7, and what is the time right now? The time going to be 38. So remaining 5 I will complete in the next video, and along with the 12 question that I have from previous IIT JEE. I don't want to exceed the video. So these are the 7 formula within which a structure is needed. Understand up to this? 5 more is there for which we will have to be familiar with the structure. Without knowing the structure, we are not able to find the oxidation number by using the formula. So bye, have a nice evening, because I don't want to exceed the size of the video. Revise up to that. In the next video, I will give you the another remaining 5 along with the IIT JEE question. Write fast. Bye, have a nice evening, sir. Bye.